Hi guys, welcome back to your new lesson. This is Lakshmikant Tiwari. I am going to teach you today Plotly and the cufflinks. Do you know what is the difference between the Plotly and the Seaborn and the matplotlib data visualization libraries? You might have noticed that in the matplotlib and the Seaborn libraries, once we plot the plot, we cannot see inside the plot like we do in the MATLAB. We cannot zoom in, we cannot the drag and the drop the plot. All those things now comes with the plotly. The plotly is really very interactive. The library plotting data visualization, the package into a Python, and you can use plotly with the cufflinks in your data visualization tool, data visualization projects. Cufflinks binds plotly and pandas data frame together, and it is really a boon to the data scientist. We will be working with the Titanic data sets, and we will be working with all these the plots, etc., and we will be drawing so many plots, and we can zoom it, zoom in, and we can the zoom out, etc. we can do in this plotly, all those things. Okay, there are so many plots. We will be learning almost every type of the plot in the plotly. And one more thing, please do not forget to subscribe this channel, and please do not forget to like this video. I have invested a lot of the time, and I am really very grateful to you. You are watching my channels and my videos. Thank you so much for watching. And now let's go ahead and start it. Plotly is a library that allows you to create interactive plots that you can use in dashboards or websites. In fact, you can save your images into a static images as well as into HTML files. Before we start working with the plotly and the cufflinks, we need to first install these. You can install plotly and the cufflink by using these commands. Simply you can write here exclamation marks and then pip and then install and plotly. Okay, so this exclamation marks make sure that our the Python code cell, Jupyter Notebooks code cell should run as a command cell. Okay, so I have already installed this plotly, that's why it will show me that everything has been already installed. Okay, so all the requirement has been already satisfied. And similarly we need to install our cufflinks as well. You can install with the pip install cufflinks. Okay, so I have already installed the cufflinks as well, and it will show it is saying that requirement has been already satisfied. Okay, perfect. So there is one more, you can see here the shortcuts into a plotly into a Jupyter notebook, that you can expand and collapse your output cell. If you double click on this cell, it will automatically collapse. Okay, perfect. So we already have here the plotly and the cufflinks. Now the question comes here, why do we need plotly and the cufflinks together? By default, plotly do not support plotting on a pandas data frame. So a cufflink is a library which binds pandas and cufflinks together. That's mean with the cufflinks, with the help of the cufflinks, we can use a plotly library or a plotly APIs directly on the pandas data frame, as we have been using in our previous tutorials in case of the matplotlib and the Seaborn. Okay, perfect. Now let's go ahead and start importing the setups. Start importing the required package here. So we need to import first here the pandas, although we will be needing here the pandas. Okay, so import pandas as pd, and then import numpy as np, and then import Seaborn as sns. We will be also needing matplotlib as well, so let's import matplotlib. Okay, so import matplotlib.pyplot as PLT. Since we are using here a Jupyter notebook, we need to also include matplotlib inline command so that our graph should be shown inline into Jupyter notebook cell. So we need here matplotlib and then inline. Okay, perfect. Now let's go ahead and import pyplot. So we need here from plotly, okay, sorry, let's say import plotly, not a pyplot. So we need here a plotly dot offline, and then sorry import iplot. Okay, and similarly let's import plotly as py, and let's import plotly dot tools as tls. Okay, perfect. Now let's run this cell, and apart from that let's import cufflink as well. So import import cufflinks as cf. Sorry, as I already have made it clear that cufflinks only bind pandas data frame with the plotly. Okay, all the plottings and the backend graphics etc is being done by plotly, and cufflinks only do the binding of the pandas data frame and plotly. So in this lesson we are going to learn how we can use line plot, scatter plot, bar plot, box plot, spread, ratio, heat map, surface, histogram, bubble and 3D plots into cufflinks and and plotly, okay, which we will be referring as a iplot. Okay, now let's go ahead, but before that let's check which version of the plotly we are running here. That we can do with the print and then py dot version. Okay, so here I am running 3.10 version. Okay, now let's go ahead and see what is the difference here, okay, between the pyplot which is we have imported as the plt, and the plotly which is iplot. Okay, so we can do like this, df.iplot, and if we run this cell it says that there is error. Okay, since we do not have the df, okay, what we can do here, we can say here the pd. Okay, sorry, it says that the pd is not like that. Let's create empty pandas data frame. We can do like this, data frame, okay, and like this, right? So now let's write here the help, and then I'll show you what it can do. Okay, so as soon as I write here df.iplot, it gives me a lot of the documentation. Okay, so this documentation says that what type of the plot I can plot with the iplot, okay, which is plotly, and this kind of the chart which I can plot with the plotly, such as a scatter plot, bar plot, box, spread, ratio, heat map, surface, histogram, bubble. Okay, there are so many type of the plot which I can plot with the plotly. Okay, and it takes other kind of the input like data, layout, file name, title, X title, Y title, Z titles, colors, color scale, etc and etc. Okay, so there are so many parameters which we can provide to make our plot, the very lively. Perfect. Now let's go ahead and let me tell you one more thing. The plotly can be worked as online as well as the offline. Okay, So how it works, the plotly first calculate the data on the server, and then it brings the data and plot it on a local server which is being run by a Jupyter notebook, okay, or Anaconda. But in the case of if we run a plotly as an offline tool, then it do all the calculation the offline, okay, then it did not fetch it do not fetch the plotted data from a server, right? Let me show you a live example how it brings the data from the server, plotly server, and then it plot offline, okay. So here we have an example, tls.embed, okay, that is the tool, and then here we have https, okay, then we have plot.ly, that is the plotly, right, and then I'm getting it from cufflinks 8 number, okay. So let's run this cell. Now you will see here a graph will be loaded, okay. So how it is working here, it is bringing this plot, okay, from the internet, and then finally it is plotting here. We can see this plot online, okay, if we copy this link, okay, and sorry, if we copy this link and paste it on the Google or Chrome, then you will get almost a similar type of graph, okay. So this is how plotly works. When we are working as online, then it draw all the graphs online, and then it brings the data and finally plot it on a Jupyter notebook. So let's make a plotly as a offline, and to work to make plotly work on the offline, we need to say here py dot offline, and then init notebook node with connected is equal to true, okay. Now plotly is going to work in a offline mode, okay, and we need to also bring our cufflink into offline mode. Then we can just go here, we can just write here cf dot go offline, okay. Now we have a plotly as well as a cufflink in offline mode. Even though if I don't have an internet, then it will just work, okay, without any problem. Now let's go ahead and generate some fake data and draw this data with the Seaborn as well as a plotly, okay. So let's go ahead. Now I'm going to save it into the def is equal to pd dot data frame, and then I'm going to call it with np dot random, that is the normalized random numbers with 100 columns and 3 rows, and then I'm going to also provide here columns, sorry, the columns which I'm going to provide here, it is just A and B column, and then finally C column, okay. So let's see its head, data frame head. Now here we have it says that it doesn't have anything like that. Yes, here we have our df, and let's see what is the shape of the df. We can get shape of df here. It has 100 rows and the 3 column, okay, perfect. Now let's go ahead and plot this data. With the help of the cufflink, we can do it very easily like this, df.highplot. It will automatically plot all these 3 columns in very interactive plot, okay. Now you see here magic has just happened, right? Now as you see, this plot is really very interactive. If I hover my mouse, I can see each and every information on the graph, okay. The value of all those 3 plots here, I can see these plots value very easily. If you want to make it a little bit more clear, what we can do here, we can use a CumSum, okay. So let's use a CumSum, okay. To use a CumSum, what we can do here is equal to df okay, and then here we have for B as well as df, and then here we have B. That's the cum sum is a cumulative sum. It will make this graph looking really very nice. Let's make it is equal to df dot c is equal to cum sum. Okay, so let's run it. Now you will see here. Okay, so here we have our these two plot. Now you can see here the value of each of these three lines. Okay, that's really great. So this is how it works. And apart from that, there are so many other tools in the Plotly which really make it very easy to analyze this data. Such as if you want to zoom some part of this data, let's say you want to analyze this data, how this data is being crossing, each other, then you can just hover it here and just pull your mouse there with the left click on your mouse. Now you can see here. Okay, so really you can zoom in and zoom out. Okay, let's say you have like this, and apart from that you can save it from here. If you just click on here, download plot as a PNG, it downloads your plot. Okay, and as you see here, the area which I had zoomed in, that area only has been saved. Okay, so let's say if you want to the pan it, okay, you want to move it somewhere like this. Okay, so you can move this graph as well. You can further zoom in and then you can finally zoom out. And if you want to just make it auto scale, then you just need to click here auto scale, and this new image will be scaled down automatically. Otherwise you need to just press a reset axis, and then reset axis will do almost everything, okay, for you. So this is the beauty of the Plotly and the cufflinks. Okay, now let's plot this same plot. Okay, let's plot the same plot in into the matplotlib. Okay, so let's see what happens here. The plt dot plot. Okay, and let's type here just df. Now you see here we have this plot. Okay, we have here a similar plot. Okay, now you can see it very clearly that here we don't have much information. Okay, but here we have really a lot of the information. Now we can really zoom in, zoom out, and we can just pan it. Okay, we can just slide this overall graph, and we can understand our data very clearly. But matplotlib, Seaborn, or inbuilt pandas data visualization ability doesn't give that much of the freedoms and the ability to analyze the data. This is the difference. Okay, now let's go ahead and let me show you the one variable versus another variable plot in the Plotly, how we can do it. Okay, df.iplot. Okay, one thing you might notice here that we need to just write here the plot instead of the plot which we have been writing earlier. Okay, so let's see if we do here the df.plot, which is generally matplotlib kind of thing, then you will see here the same kind of the graph we are getting. Okay, so as we have got here with the plt.plot, and the same kind of the graph we have got here. But you see here, if I do here the iplot, it changes my matplotlib into a Plotly. Okay, now here we have a df.iplot, and if you press here shift and the double tab, you will see here it asks about the kind, and then it asks about the data. By default the kind is scatter, and the data is none. Okay, and we have also the x and the y values here, you see. Okay, so let's go ahead and set x and the y values, and let's see then what happens. Here we have a df, and we are going to plot here a and y is equal to b column. Okay, let's go ahead and plot this. You will see here something, the jiggling, the very wiggly jiggly kind of the graph, right? Perfect. Now let's go ahead and make this line plot into a scatter type of the plot. How we can do this? Okay, although the kind is already by default set to the scatter, what we need to do here the marker, which marker we are going to use, we need to just remove these connecting lines. Okay, to remove those connecting lines, what we can do, we can just set here the mode is equal to marker. Okay, mode is equal to the markers. Now you will see here this jiggly wiggly really has become a very kind of the scatter plot. Now you can zoom it here, and you can then finally move your graph with the pan ability, and finally you can zoom out your graph, you can auto scale it, you can go to the home axis, right? You can do a lasso selections kind of this, right? Let's say you want to just save this much of the data, then how you can do it? You just select this much of the data and just download this PNG. Now you will see here that much of the data has been only highlighted and other data is into the background. So these features are really very beautiful in the Plotly, and these features really make this Plotly very very handy to all the data scientists and the machine learning enthusiasts. Now let's go ahead and change the size of these markers. You can simply change the size of these markers with the size is equal to, by putting some numbers. Let's make it 15. Now you will see here the size of the marker has been increased. Now let's make it 25, and the size of marker has been really increased too much. Okay, so this is how we can plot a line plot and the scatter plot. Let's go ahead and try to plot some kind of the bar plot. Okay, to plot a bar plot, I'm gonna say I'm gonna fetch a new data, the Titanic data that is really very famous. Okay, so the Titanic, okay, is equal to SNS. We already have SNS load data set, and you need to just pass here a Titanic, and you see here we have the Titanic here dot head. Perfect. Right, so we have now the Titanic data. Let's plot our the bar plot, and in between the survived and the sex. Okay, so let's go ahead and do with the Titanic dot iplot. As you see here, this kind, okay, we can work with the kind, and kind provide the facility. There we can set here a bar plot. Okay, so let's go ahead and set a bar plot, kind is equal to bar. But before that, let's insert so many few cells behind the working cell, so that we can get enough space here. Now we have here a bar, kind of a bar, and let's assign x data. I'm gonna assign here a sex, and the y data I'm gonna assign here survived. Okay, so let's plot it. Now once I plot it, I can see it very clearly that the female candidates have survived more as comparison to the male candidates. Let's go ahead and count male and the female counts on board the ship. We can do with the Titanic, and then sex dot value underscore counts. Okay, so here you see we have 577 male candidates and 314 female candidates, right? And out of the 314 candidates, if you see here, if we zoom it, you see here, if we zoom this, we will get some kind of the the value there. Let's zoom it further. Okay, so the 233, right? So the 233 the female candidates were able to come, the 333 female candidates survived in the Titanic. Okay, so this is how it worked. And now let's go ahead and take it into a little bit more detail. Let's say if you want to add here the titles and x-axis and the y-axis, then how we can do this? This is really very simple. As I had shown you here, we can add x titles, y titles, as well as a title there. You need to just write here a title is equal to survived, and x title is equal to sex, and then y title is equal to survived. Okay, now let's plot it. Now you can see here it has survived. Now the total count of the survived, we can say something like this: the count of the survived, and here the survived plot, and there is a sex male and the female. Okay, perfect. Now let's go ahead and see how we can get something kind of the bar plot, but with the stack plot. Okay, let me show you what I'm talking about here. Let's go ahead with our original data frame with the df and work with the pie plot there, and set here the kind is equal to the bar. Now if you see here, we have something this kind of the bar here. Okay, you see here there is no difference between there is no gapping between these plots. Then how we can put a gap between these bars? We can set here a bar gap. Okay, and bar gap is equal to, let's set it 0.4. then in this case, if we zoom in, you can see here there is a the gap between the bar. Okay, and if we set it 5, then you will see here there is some a larger difference. Now if we remove this bar gap, now you see here there is very less difference. Okay, perfect. Now let's go ahead and let me show you how can we change the bar mode. Okay, what is the bar mode? Let's say here bar mode. The bar mode provides the 3 type of the mode. Okay, one is the overlay mode and then the stack mode, although you can get all the information from here. If you see somewhere, we should get here a bar mode. Okay, that is a mode. Then yes, we have here 3 type of, okay, group, stack and the overlay, right? Perfect. So let's go ahead and see here. If we say here bar mode as a stack mode, then what happens? Now you see here our the bar plot has been stacked on each other. Okay, so you see here the A, B and the C, right? Now we can set here our bar gap. Okay, let's set our bar gap to 0.5. Now we can see here the gap is a little, the very high between the bars. Perfect. So this is how we can set our bar plot in a horizontal direction. But let's suppose that if you want to make it into the vertical direction, then how you can do it? You can just simply make it here H, that will be a bar H. Okay, now these bar will be plotted the horizontally. Okay, and the axis will be the vertical. Okay, and we can also zoom it and we can see it. Okay, although this plot is not looking good, but it's good to know how you can do this. Okay, now let's go ahead and see how the plotly and the cufflink themes work. Okay, let's go ahead. I would like to come here at this location. Let's make here the cf.getThemes. You see here these kind of the themes we have. Okay, now let's go and set these kind of the themes and see what happens and how we can get a different type of the plot. Okay, so let's just copy this and paste it here, as well as let's set another type of the theme with this cf.set_config file, and then theme is equal to Perl. So this is the default theme. You see here the same kind of the graph we are getting, but let's say sorry, we need to bring it up. Sorry. Now let's go ahead and set ggplot, and we will get something like matplotlib. Okay, a Seaborn type. Okay, so this is a kind of the Seaborn background. Now let's go ahead and set solar theme. Okay, we will get something like this. Now let's go ahead and set space. Now we get something like this. Let's go ahead and set white. Now we get like this. And if we set a polar, then we get something like this. Okay, and here we have this type of theme. If we set this, then we get something like this. Now let's go ahead, and I would like to set here a polar. Okay, and here we have a fantastic. Now let me make it white. Now we have something like this, which is really very cool. Now let's go ahead, okay, and move to the box plot. How we can draw a box plot? Let's go ahead and draw it and see how it can be done with the df.iplot, and here we need to just pass a kind is equal to box. Okay, now we get here a box plot. You can see here we have three the column A, B and the C, and here it has a upper quartile. And one of the beauty you can see in the graph, which we had not seen in Seaborn and matplotlib, if we hover on these quartiles, we can set each and every information, like what is the maximum value, which is 7.57, and the quartile, third quartile, which is 75% value. I mean the 75% values of the column A is less than 4.42, and the median is 3.28, and the first quartile is 2.31, and the minimum value is minus 1.84. And the same thing happens here in the B as well as in the C. You can see this is really very beautiful, and this is the fantastic Plotly library, which you can see, which you can use, and you can use in visualization during your data analysis. Now let's go ahead and see how we can convert these line plots into kind of the area plots. Okay, kind of the field area plot. Okay, so the area stacked plot gets only when values are the positive. And you see here minimum value in this is around minus 14. So what I'm going to do, I'm going to add 15 in each of these plots, okay, values. So just add here a 15. I'll tell you why I'm adding here 15. Because if we work with the area plot, and if we want to stack one area onto another, then either plot should have a negative values or a positive values. Otherwise the stacking of the plot in the area plot would not work. That's why I'm going to do this. Okay, so here we have a plus 15 and then plus 15. So in this case we will get I think, yes, we still have, so let's make it 20. Okay, I think yes, we have all the positive values. Okay, so now we have all the positive values. Let's go ahead and plot this as an area plot. Okay, now come back here. We are going to plot that line plot as an area plot. Okay, perfect. But before that, let me plot that as a line plot first, then I'll go and plot this as an area plot. Okay, so df.iplot, and here we have a kind is equal to area. Okay, you see here with this we have kind of the area plot, but the fill is not true. Okay, you see here, if we type here shift and the tab, there is a fill. Okay, if we type here a fill is equal to the true, now you will see here we have a fill is equal to the true. Okay, and apart from that we can toggle these plots as well. If we click on the A, then A will just go, and if we click on the B, then the B will just fade out. If we click on the C as well, all the plot has been gone. Okay, and we can now bring plot A, and similarly we can bring a plot B, and we can then bring a plot C. Okay, so this is how it works. Now let's go ahead and work with the 3D surface, and we need to first create a random sample data for a 3D surface. So let's create the df3, the data frame 3 with the pd dot data frame, And here we are gonna set here the x, that is the x-axis, and the value of x-axis is gonna be 1, 2, 3, 4 and 5. Okay, and although let's make it 1, 2, let's make it 20, 10, 20, 30 and then 20, and similarly we are going to make it 10. Okay, and now let's go ahead and make y-axis is equal to similarly we have here the 10, 20 and then 30 and 20 and then 10, and let's make z, okay, sorry, oops, z axis, and in the z axis I'm gonna make it 10, 20, 30, 40 and 50, right? So here we have a df3, sorry, here we have a df3, oops, it says that there is error. Oh, this is error, right? We have now got our data frame df3 of a 3-column graph x, y and the z. Now let's go ahead and draw this into a surface plot, a 3D surface plot. How we can do this? With the df3 dot iplot, and then I'm gonna set kind is equal to surface, and now you can see here we have got something, you know, a surface plot. Okay, here we have our z axis. If we reset, we can reset axis from here. Okay, so here we have x value and here we have y, and then we have here a z. Okay, so this is how z is you know, increasing, right? And then we have x increments and then y increments and then finally z. Okay, so the z is increasing too much. Then what we can do here, the 10, 20, 30, and then we can make it 20 and we can also make it 10, right? So this is how we have our z axis. Right, now let's go ahead and set here some coloring scheme. We can set this coloring scheme with the color map, with the color scale, and we have a color scale here RDY LBU. Okay, and now we have something like this. Okay, perfect. Now let's go ahead and now we are going to generate we are going to use data gen function of a cufflink itself. Okay, so how we can do that? Sorry, we can do like a help and then cf dot data gen. Okay, and if we enter, then we can see here this is cufflinks default data generation tool. Okay, and there are so many there are so many examples in this documentation and you can understand it better. Now let's go ahead and type here cf dot data gen, and then I'm going to create here a sine wave, and in this sine wave it takes the two input n and the increment, and n is going to be the 10 and increment is going to be 0.25, and then I'm going to use iplot, and in the iplot I'm going to pass here a surface, right? And once we have a surface, let's just plot it. Now you see here what we have. Okay, this is really fantastic. Okay, so this is how we can see a 3D plot into a plotly, and you can see here this is really very interesting. We can see in different axes, we can zoom out, all those things we can do. Okay, see how we can do this, right? And then we can pan it there, we can, you know, we can rotate it. See here how we can see it. Then we can rotate it into the different directions, right? This is fantastic, really fantastic. Okay, now let's go ahead and let me show you a 3D scatter plot. Okay, so to show you a 3D scatter plot, we need to do a cf.datagen, okay, dot scatter. Now here we have a scatter 3D in a 3-dimensional scatter plot, and you see here it needs number of categories and n. Okay, so here I'm going to pass total number of categories is 2 and total number of points is 150. Okay, and the mode I'm gonna pass here stocks. Okay, now you see here we have x, y and the z, and these are things. And once we have this data frame, let's make it iPlot, and now we have iPlot. Okay, and here we can set a kind is equal to the scatter 3D. Okay, and x-axis I'm going to set here x, and in the y-axis I'm going to set here y, as well as in the z-axis I'm going to set here z. Okay, perfect. Let's go ahead and plot it, and I'll show you. You see here how beautiful is this. Now we have here a scatter plot in 3 dimension. Okay, perfect. Now you can zoom it, you can zoom out, and then you can save it. Whatever you want, you can do everything. Okay, now let's go ahead and let me show you a spread plot. Okay, what is the spread plot? So we are going to utilize our df data frame. We can put it here A and B. So this is our df data frame. Sorry. We have here our df data frame. Let's plot this, and I'm gonna use kind here spread, and now you can see here. So this says that how these two plots are spreads to each other. Okay, and it starts with this with this a-axis, and it says that here a green, that's mean A is larger than the B, but after that you get here the A is always smaller than A. Sorry, A is always smaller than the B, right? So with the spread plot, you can understand how two variables are changing. Okay, what is the speed of those two variables? How they are changing one versus another. You might have seen in a cricket score or a football score, if they compare the performance of the two teams throughout the time, they shows this kind of the plot, how they are gaining one versus another. Okay, so you can do like that. Let's go ahead and work with the histogram. And in the histogram, we have 4 kind of the basic parameters like a bar mode, bins, and histogram norm, and the histogram function. So let's go ahead, work with the df.iplot and set here kind is equal to hist. And once we have a kind is equal to hist, and then I'm gonna set here bins, where bins is equal to 25, and then we can set here bar mode, and we can set here bar mode is equal to group, right? You see here it says that this is this says that this is an invalid syntax. Let me see where it is. Yeah, here. Okay, now you see here we have here a histogram. Okay, earlier we had a bar plot, but now we have a histogram. Okay, and similarly we can say here a bar gap, and if we see it, bar gap is 0.5. now you can see here bar graph is 0.5. okay, and if we see here the bar mode as a stack, then you can see here one bar is stacked on another. And if we say here overlay, then we will get here overlay bar. Okay, perfect. So this is how it works, histogram. Okay, now let's go ahead and work with the bubble. Okay, so I'm gonna show you a bubble, 3D bubble, with the help of the data generation of a cufflink. Okay, so we need to first generate a bubble data generation, and if we see here the input, it needs number of categories and total number of points. Here we have a number of categories 4 and number of points is 5, and then mode, I'm gonna generate a data of stock mode, and then I'm gonna say here I plot, and then kind is equal to bubble 3D, and then finally x is equal to x, and then y is equal to y, right? And finally we have here z is equal to z. Perfect. Now let's go ahead and see this. It says that the key 12 is error. This says that something, let me see. Okay, I had forgot to pass a size here. Let's pass here a size is equal to size. Now we have here our bubble, the plot in a 3 dimension. Right, now we can see it here. Okay, so this is a bubble plot in a 3 dimension. Perfect. And now let's go ahead and see how we can plot a heat map into a plotly and the cufflinks. That will be our last plot. Okay, so the CF dot let's first generate the data for a heat map. We can do with the CF dot data gen, and then a heat map. Then we have here a 2020, and then here we have a I plot, and in the I plot we have a kind is equal to heat map, and then finally we have here color scale, and in the color scale we have a spectral, and then finally we have a title is equal to cufflinks. Okay, heat map. This says that there is somewhere invalid keyword, color scale. Let's see. Yes, now you see here the cufflink heat map, right? So this is how now we can zoom it here. We can zoom it here and we can see inside what is happening there. Okay, perfect. That's the fantastic. Now the great job. It has been almost more than 40-50 minutes, and I am sure this is one of the best library which you can use into data visualization while working with your machine learning projects. Thank you so much for watching this video. Please do not forget to subscribe this channel. Bye bye. Have a nice day.